In this lecture, we will consider frequency deviation and phase deviation in case of angle modulation. So let us consider the modulated signal. So that is the modulating signal MT, AM cos omega MT. So second, the carrier signal. So that is the carrier signal. Now we need to write the frequency modulated signal. We have already discussed in our previous lecture what is the frequency modulation and how can we represent the frequency modulated signal. So here we are going to write straightforward the frequency modulated signal. So like we are considering the frequency deviation. So in order to calculate the frequency deviation, we first need to write the instantaneous frequency of the FM signal. So that is the instantaneous frequency of the FM signal. So where omega c is the frequency of the carrier, kf is the sensitivity of the modulation, and mt is our modulating signal. So if you want to know about the modulating signal, so that is the am cos omega mt. So you can just insert the mt from equation 1. So you can say use 1 in 4. So in that case, the instantaneous frequency will be equals to omega c plus k of f am cos omega t. So in this case, your frequency deviation is that part. So you can say that, okay, the frequency deviation del of f is equals to kf am. So that is the frequency difference between the maximum frequency deviation and the minimum from the minimum frequency deviation. So del of f is equals to kf and am. So that is the frequency deviation in case of FM signal. So you can use an alternative way in order to calculate the frequency deviation. So like we can use an alternative method. So that is a very straightforward method, but you can use an alternative method in order to calculate the frequency deviation. So as from the deviation, the frequency deviation, so we know that the frequency deviation is the frequency difference from the maximum deviation to the from the minimum frequency. So we can just write the instantaneous frequency. So that is written in equation 3, like equation 4. So that is the difference So due to that negative sign, this can be cancelled out. The remaining is from equation 1 we know that mt is equals to am cos omega ct, and we know that the maximum cos theta is plus 1 and minimum of cos theta is minus 1. So this equation can be rewritten as, so we are writing this 2 because this is in twice position, in twice direction. So k of f is constant, so mt is your so that is the frequency deviation. So same formula, so you can see both formulas are the same, but you can use this method or you can use this method. By using both method we are ending up with the same results. The second thing that you need to calculate the phase deviation. You know that the frequency deviation basically is the frequency difference of the signal from the maximum frequency deviation to the from the modulator signal. The second is the phase deviation. Now, in order to calculate the phase deviation, you need to write again the modulated signal. So, f of mt is equals to ag So phase deviation is basically the maximum of that part. This is basically the phase. So it means that the maximum of this one, maximum of that one will give you the phase deviation. So you can denote phase deviation with beta. So that is and we know that mt is equals to am cos omega mt. Am is a constant, you can take it out. and the integration of cos is sine omega mt, and now this is the additional factor omega mt, so we have to divide it with omega mt. And we know that the maximum of sine is equals to 1, so it means that this is also known as modulation index. This is also known as modulation index. So you can represent in both cases like using the modulation index or the frequency deviation. So we know that this whole portion, that del of f is equals to k of f am, and then you can use that here in this part. So and the remaining thing is that so that can be equals to 2 pi delta f. This one is equal to 2 pi f of m. So beta can be equals to del of f. So like you can represent both signal like f of, you know that the phase modulated signal is basically equals to AC cos omega ct plus AP m of t. So that can be written as so in case of phase modulation, so that is your frequency deviation. So you can write AC cos omega mt. But in case of FM, so you can represent your FM signal in both way, like in your frequency modulation case, your modulation index will be equals to k of f am divided by omega m. But in case of PM signal, your signal will be AC cos omega ct plus beta cos omega mt, and in that case your beta is equals to k of f am, like that is your beta. So I hope you understand what is the frequency deviation and what is the phase deviation and the modulation index of angle modulated signal. The second is the deviation ratio. The second is the from the term ratio, so it means that it is a ratio of from one quantity to the other quantity. So maximum the deviation ratio can be defined as the maximum deviation to the maximum modulation frequency. Like it can be defined in two ways. maximum deviation divided by maximum modulating frequency. So that is the maximum deviation, like in FMK. So this is your maximum. So this is your maximum frequency deviation. And in case of single tone modulated signal, so that is your maximum frequency. So you are like your omega mg is equals to 2 pi f of m. So that is the maximum frequency of the modulating signal. The second term is the percentage. So like you can also represent in term of percentage modulation of FM signal. So percentage modulation of the FM signal is also a ratio which can be calculated using the ratio like the actual frequency deviation divided by the maximum allowed deviation. Actual frequency deviation, like maximum allowed deviation. So I think in today's lecture we have completely discussed frequency deviation, phase deviation, and the deviation ratio. So but if you have any question, like any comments, you can just write down the comments below the video so that we can better improve this lecture. And secondly, you need to continuously watch our video in order to understand the communication and in order to understand the following lecture. So I hope that today the concept of the frequency deviation and the phase deviation is clear to all of you. But if still you have any suggestion or any question, you can write down in the comments. Thank you for watching the lecture.